Yes,
Over to the
I want
minutes.
to make a motion to approve the minutes of the December 20th meeting.
Second.
All in favor?
Aye.
Aye. Thank you.
Okay, so now we're on to the interconnect meeting. Thanks everyone for coming. Let's start with Hingham. Can you let us know how things are going?
Well, we don't have, hold on. John Amonte's not here. Russell Tierney's not here, so we have Darren. I got a couple more coming in.
Okay.
It just reminded us also.
Good morning, everybody.
Morning.
Morning. So who do we have here from Hingham?
So you got me from Suez. I don't have I sent a reminder to Russell.
Okay.
I hadn't gotten a response from him.
Okay. Well, maybe you can, Darren, you can give us an update as to how things are going.
Sure.
And any issues with Cohasset or how things are going working with Cohasset.
Well, so things have been going well with Cohasset, and I believe we have a chlorine analyzer in place now, and we have plans on getting that hooked up to SCADA by, I believe we said the deadline was going to be the end of March. And so I think that we have SCADA coming in within the next week or two. So just to be able to monitor the chlorine and pH.
Good. And how's everything going with the transition from Aquarian to Hingham and Suez?
So that was a nightmare.
Okay.
I can't even tell you how bad that was. But we pushed through, and we got through it. So Aquarian did everything they could possibly do to boggle it up.
Okay.
So we're in. So we've done that. We're in now. So as we're getting everything, we're actually fixing things and starting all over again. It's kind of a good thing. Suez will be transitioning over to Veolia on the 19th. So, but that should be more of just a branding change than anything else.
So you're just changing your name?
It pretty much Veolia's taking over Suez.
Okay.
For the Northeast area. They don't expect any changes other than just software usage and whatnot. But
is that going to affect the billing?
It should not, Brenda. It should not.
Words.
Yeah, no, it should make things actually. It's going to be easier, I think. So.
Okay.
We'll be down to like 2 bidders the next time we put this contract out to bid for ops.
Right. Yeah. Yeah, things will actually probably be easier somehow for whatever reason. Some of the billing issues to get carried over from the Jersey Suez, and they have different issues that they actually try to bring over here. So it makes things more complicated than it needs to be. So Veolia will it'll be a nice change. Won't be any billing changes, but it should be easier, more simplified.
All right, thanks, Darren. So you work with Brenda on that any transition, please?
Yep.
Okay,
Yep,
thank you.
we stay in contact with when she needs the reads and stuff. Between myself, Leanne, Jim Stanton, hopefully we get everything to you on time whenever you need it.
Yep. Yeah, it's just dealing with corporates sometimes a little bit more difficult.
Yeah, that's the good thing that will change out. So
Okay. All right. Well, I look forward to it.
Lee or Steve, any questions for Darren?
Not necessarily. I would have liked to have talked to John, but since they're not here, we're going to have to postpone it to the next meeting.
Okay.
No question. I'm on the Ware River Advisory for Cohasset to Hingham, so they're doing a good job over there.
Now,
Actually-
excuse me, Steve, when's your next Weir River meeting? Is it about 3 months?
It actually should be coming up shortly, sometime in February.
Yeah, Steve, they're supposed to get you the rate study or the whatever those 2 studies before the meeting, though.
Correct. That's what we've been waiting for. So
Yeah, that was supposed to be mid-January, I think, wasn't it?
that's why I said February. Yeah, I haven't heard.
I think the reports were supposed to get here mid-January, and then the meeting was in February.
Correct. So I'll find out from the chair of that committee where they are.
So we did just have a sanitary survey. I can share that with you if you like, but that was, we had an amazing sanitary survey from a disgusting transition. A lot of praise from the DEP. So.
Okay, so is there anything else? Do you have any questions for us, Darren?
I don't at all. I'm in contact with Jonathan.
Yeah, I just reminded Jonathan he needs to be on this call because I don't know if he had anything to report about the crossing station, Whitney Crossing. Hold on. He's coming on now.
The other thing I'll say, they have fixed the issue with the markouts. We haven't been getting bad markouts in Cohasset anymore from DigSafe, which is a positive. Thank you guys for taking care of that.
Yeah, that was a nightmare.
Yes, it was. Yep.
Jonathan, is there anything you want to report on the crossing? You're muted.
No, nothing significant. We've been doing some legwork on designing a hypochlorite addition, but right now we're waiting for some engineering paperwork to be filed.
Okay, we're still working on the true up.
Yeah, true up I have. It's about 5 million gallons, 15% shy of where we'd like to be. But yeah, roughly it's about 500,000 gallons, or 5 million.
Okay. Darren, thank you for joining us. I think we're done with the interconnect meeting unless anyone has anything further.
I'm all set, and Jonathan and I'll just be reaching out to you later, before the end of March, obviously, and we'll, we have our SCADA stuff. I want to get our SCADA hooked up, so we see the pumpages. We just want to be able to get the chlorine and that. But we could talk about that.
Sure.
later.
Yeah. Another update is that we did install a chlorine analyzer there as well. It's operating. It's just not tied to our SCADA yet. We're waiting for our own SCADA upgrade.
Also, board, what is your thought on, I want to reach out to Hingham again about the contract renewal. So if you guys are okay with that, I'll reach out to Russ and try to find out what the game plan is on Hingham's side as to who's going to be the group that'll work to get that renegotiated.
Yes, please do that.
Okay.
Okay. If nobody has anything left for me, then
No, thank you for coming today.
Yeah,
Thank
no
you very
worries.
much.
No,
Thanks,
pleasure
Darren.
meeting you all, and nice seeing you, Steve, Brenda, and
As well.
everybody. Fred,
All right, Darren, thank you.
take care, guys. Have a good rest of
You
your day.
too.
Stay warm.
Thank you.
Bye. Bye-bye.
Okay, next we have up the two presentations for the RFPs, and we have Tish and Bond first. We're ready for that.
Who's going to be doing the presentation and who needs to be made a co-host?
If you could, this is James Collins. If you could make me available to share my screen, I'll be sharing it.
Okay, I noticed that we also have a lot of Tetra Tech people on this portion of it.
Is there any objection to that?
James asked me the same question yesterday about his attendance. It's a public meeting. I've never done this via Zoom. So it's up to you guys what you guys want to say. I didn't know how to answer the question yesterday when James asked me this exact question. Can he stay after his presentation's done? And I said, I don't know. It's an open meeting on Zoom. I don't know how I can say no. So I don't know what to say other than we had a discussion about it.
Jason, it's really kind of, and it's up to the folks that are presenting. But again, if this was just in a regular big room, both parties would be there at the same time. So you could leave it up to them if they want to go into the panelist side. But again, it's up to the chair too, what he wants to do, and up to the presenters.
I think unless the presenters have an objection, this is an open meeting and they should be allowed to stay on for the full duration if they choose to.
Yeah, I don't think there's any objection on our end from Ty and Bond.
Okay.
No
Tetra
objection
Tech?
here from Tetra Tech side either.
Okay, thank you.
Well, if I could just ask one thing, if people could just sign into the chat, your name and the company you're with, because I don't know half of you. And I want to make sure the meeting notes reflect that you're with the right company.
Thanks, Brenda.
Thank you.
The first one should have a comeback.
Can everyone see my screen? I hope so.
Yes.
Yes.
All right. All right. You want to start off, Tom?
Just signing in real quick here. Thank you. Good morning, everybody. My name is Tom Mahana. I'll be starting off this presentation from Ty and Bond. There's five of us. There's five of us on the call from Ty and Bond here this morning.
Thank you.
Just wanted just very quick overview of the firm and in our project team. So a little bit about our company. We were established in 1911, so we're over a 100-year-old firm. We have over 400 professionals located throughout our 12 offices in the Northeast, which are located. We have offices in all the New England states except Vermont, and also we have one in New York. Next slide, please. This slide just represents just a very quick, brief summary of all of the capabilities of our firm. We're a full service firm. These represent the five different core services that we provide. But basically what we're trying to show here is that we provide, for this project, we would provide all of the services required for this project with in-house staff. We would provide everything with the exception of survey and drilling services, which we would subcontract out. So our firm, we provide everything with in-house staff from the environmental permitting that would be required all the way through the design, building design, process treatment design, all the way through geotech services, and we also do SCADA programming. So full service firm, everything is done in-house. We would, if selected, we would utilize a local surveyor. We've used Morse Engineering, for example, on our Situate projects, which is a local civil firm if we next slide. So want to just talk a little bit about our project team. So on the call today are 5 key members of this team. Our project team is headed up by myself. I'm a vice president / project. I will serve as the project director on the project. A little bit about my experience. Of over 30 years of experience. I have multiple projects, similar projects that I've completed, similar to what this project would be throughout the years. James will be our project manager. As you can see, he has over 16 years of experience, including 12 specifically with GAC type treatment systems. John McClellan is our technical advisor on the project. John is with us here also this morning. John's kind of our in-house water treatment expert. He provides a lot of technical expertise on various different treatment projects, drinking water projects. And he would be supported along with James with Heidi Baird and Derek Belanger. They're both like project engineer level that would do really the kind of the nuts and bolts design. And all 5 of us have collaborated on multiple projects. We're currently working on many similar projects to what Cohasset is looking for. Particularly, we're currently working on projects for Aquarium, Littleton, Dudley, Mass. We've recently completed projects in Scituate. So we've tried to establish a core team here that has a lot of similar experience to what Cohasset needs for this project. Next slide. Just quickly, just a little bit about our project management approach to projects. We maintain one point of contact, which would be James on this project. This just represents kind of some of the key points of our project management approach to make sure that we have a deliver high quality project. All of our staff, all of our technical staff participate in various levels of project management training to make sure that we provide a consistent delivery method on projects. Next slide. And this is just a slide representing our expanded project team. This represents a number of individuals throughout the firm that would be involved in this project in various capacities. And all of the people represented on this slide have all collaborated on similar projects recently within the last few years on projects that either James, John, or I have led on for various treatment projects. Next slide. So I'd like to turn it over to John McClellan. So he's going to talk a little bit more about the specific technical requirements for your project.
Thanks, Tom, and good morning, everybody. So our understanding of this project is that there's 2 components to it, really. The first one is a GAC, granular activated carbon system for removing TOC, which is a DBP precursor. And the other aspect of it is to convert the plant from gaseous chlorine to hypochlorite chlorine system. Next slide, please. Our understanding again is that the design basis for the GAC component of the project has already been determined. A pilot study has been conducted by others. And this slide basically just shows what the basis of design for the GAC treatment system is going to be: flow capacity, number of vessels, and so forth. The gaseous chlorine conversion is, as we understand it, part of the scope of this project for us, and we would determine the design criteria as part of the design. Next. So the next couple of slides just illustrate that our experience on GAC pressure vessel systems, and also importantly for this, dealing with Chapter 149. We've done a lot of SRF projects, and as you can see on this chart, several of them in Massachusetts. Many pressure vessel designs and a number of pressure vessels with GAC treatment design as well. For Aquarium Water Company, South Central Connecticut Regional Water Authority are 2 of our large clients, and then also many Massachusetts municipalities and water systems. I won't get into the details of these unless anybody has questions on the specific projects. Next slide, please. This slide basically is a similar listing of our project experience with chlorine conversion. Some of these are fairly large plants, Aquarian Water Companies. Putnam WTP is a 25 MGD plant. We've also done large plants for the Metropolitan District in Hartford, Connecticut, Central Connecticut Regional Water Authority. So in short, we have a number of projects for chlorine conversions under our belt, and also Massachusetts municipalities, including State Revolving Fund and Chapter 149. Okay, next. Now I'm going to turn it over to our project manager, James Collins. James.
All right. Thanks. Good morning, everyone. So as John described, some of the sort of the major process design decisions have been selected already for this project. So now the project's kind of moving into the delivery phase for designing the water treatment plant upgrades. So one of the keys for project delivery is managing and reducing the risks associated with the project. And from reviewing the project, there's several that kind of jump out to us as being critical for project success. First one being controlling project costs, dealing with permitting. With any water treatment plant upgrade, there's always going to be technical challenges and decisions that have to be made, and also thinking about the project schedule. So I'll just kind of jump into each of those quickly a little bit. So in the RFQ, it included an estimated cost of $3.6 million. So we just kind of looked at several current water treatment plants that recently just went to bid or are in right around the final design phases as just a point of comparison for, looking at project costs. So Westfield Water Treatment Plant is 400,000 pound GAC vessels, which is a similar size to here. That one just went to bid in December. We got bids in, and that was a $12 million project. Dudley, Mass Water Treatment Plant, which has two 40,000 pound GAC vessels, chemical feed systems, simple metal building. That one came in at about $6.5 million. And then the Dracut Water Treatment Plant, which was iron and manganese, but similar 5 pressure vessels. But that one had some backwash tanks and pumps, which would be a similar need to this project. And that one came in at about $11.6 million. One of the biggest risks right now is project costs are escalating faster than we've really ever seen in the recent past. We're seeing now project bids are coming in 10 to 20% higher than estimate on a lot of jobs because of the current bidding environment. One thing that's been hit particularly hard are GAC vessels. We've seen costs go up 20+% on vessels that we've had go out to bid recently. So thinking about this project, just the 3 GAC vessels that are required, you're getting close to $1 million just in the GAC vessels themselves, not including building and other ancillary requirements. One of the things driving that and talking with general contractors is they're seeing delays in materials, cost escalation for materials, as well as staffing shortages. All of those are impacting their costs. So one of the keys for project delivery is making sure that your cost estimates are as close as possible, and then also controlling costs as you get into construction so you're not having escalation once you start putting shovels in the ground. So this is just a quick graph looking at some of our recent projects, where the light blue line is our final OPCC, so opinion of probable construction cost. The light green bar is going to be the low bid cost that was selected for the project. The dark green bar was the final cost for the project. And then the red diamonds is the change order as a % of the contract price. So you can see we've done, and for projects of similar sizes, we've had good success with predicting bid prices, but also equally as important, our change orders on these projects have all been well under the industry average of about 5%. So we're averaging under 3% for change orders on a lot of projects that are very similar size and scope to the project here for Cohasset.
Can I ask a question on that?
Yeah, absolutely.
So it seems like we've come up with a number ourselves of the 3.6 million, but you would do a separate cost estimate. Is that correct?
Yeah, throughout every major deliverable, 25%, and then whether that's 50, 75, or 90%, we would track a a cost estimate with every sort of milestone within the design process. Every time we make design changes, that will impact the costs.
Okay, but I guess my question is, before we started construction, would you be doing an estimate to see if our 3.6 million is in the ballpark? Or because you might say, no, you're really at 10 or 11 million, and then we have to reevaluate.
Yeah, I think that's why we would do throughout the project. So as soon as we get the 25% design done, which is the main scope that was included in the RFQ, one of those deliverables would be an updated cost estimate. So you would know within the next couple months what our opinion of the project cost would be. And then that would also be updated even up until the final design, right before going to bid. We would have a final cost estimate that we would be able to compare to the bids that come in on the project.
Now not having done the design and everything, you're talking about all these costs coming up. Do you have reason to believe the 3.6 million is not an accurate estimate? Just I think it's in back of the envelope.
Based on the proposed scope of work and the current bidding environment, I think that's going to be a challenging number to hit. You're going to have to make some tough design decisions, and some of it depends on the design. Do you need additional tanks to break head before you go into the GAC vessels and repumping? All those design decisions have a big impact on capital costs, but just based on recent bid numbers for similar size projects, I think the 3.6 is going to be an aggressive number to hit.
Based upon recent projects, where are you seeing them come in, similar projects?
So I think
Dudley would be a good example, Jay.
Dudley's probably the closest. It's sorry, I went too far. So this one is two 40,000-pound GAC vessels. You're proposing 3. So it's a little bit bigger in terms of the equipment. This one does not have any tankage involved with it. And it has a simple pre-engineered metal building. So that one's coming in at 6.5 million. There is some site work and piping that goes along with that. So some of those items will impact the cost for your project in terms of how much yard piping do you have to do. If you need tanks to break head and then repump through the GAC vessels because of the additional head loss, all those would impact the cost as well.
So I think what you're probably saying is that we could be double the 3.6 million.
Without getting into all the details,
yeah.
It's reasonable.
Okay.
It's possible.
All right. No, it's very helpful. I appreciate it. These are really important things for us to know.
Yeah.
Thank you. I'm sorry to have interrupted.
Nope. Yeah, feel free to jump in at any point. This doesn't need to be a lecture. So okay. Feel free to jump in. Okay. Any other questions before I move on?
Nope.
Okay. The other aspect of this is permitting. Permitting is always going to be a challenge. Mass DEP does have a lot of growing experience with GAC, primarily driven by all the PFAS work that's going on in the state. And we've worked with Mass DEP on GAC projects across the state, and there have been some oddities in the permitting process with GAC. One of the things that's come up on some projects has been arsenic. GAC media does have just naturally occurring arsenic in the media that will kind of leach out under initial startup. The Calgon F400 that was proposed in the pilot test report is one that is known to have elevated arsenic on startup. So we have seen DEP put arsenic limits on some of the designs. It's not universal. It depends on the regulator you have, but those can have a big impact on your design. From media selection, you could have to purchase acid rinsed media, which increases your costs fairly substantially for the media itself. Or you may also have to consider a filter to waste capability so that you can flush the arsenic out before putting it online. So really early and often communication with DEP is what's recommended. That also helps with getting your permit approvals through much faster. We've been able to get turnaround sort of in the 3-month time frame with DEP by working with them early. When you don't work with them early, that permit review process could be 6+ months. So permitting can be really a critical factor for project success. Technical challenges, again, as with any water treatment process, there's always going to be technical decisions to be made. When you have large pressure vessels, humidity control is always going to be a challenge. These things love to sweat in the summer because you have cooler water going through the steel vessels, which will cause sweating on the piping and the vessels. And there's various ways to deal with that. Some facilities we've designed just let them sweat and then deal with it through floor drains or gravel or other things to contain the moisture. Other systems go all the way to dehumidification, so that there is no sweating, but that comes at a capital cost. We've also worked with some facilities, which is the picture on the right, of actually doing spray insulation on the tanks so that you don't have to, it's a little bit high on the capital cost, but doesn't have any annual O&M associated with it. Another item that came out of reviewing the project is the future expansion can also be challenging. The design calls for 3 current with space for a future 4th GAC vessel. These vessels are significant in size, the 40,000 pounders, where they're 25,000 pounds a piece, empty, 27 feet tall. So moving these things around can be very challenging. So using cranes is often the easiest way to do it, but that also has impacts when you already have a building put around it. So one option we've looked at recently for a similar project where we had to look at future expansion was roof hatches, but just putting in a roof hatch on a pre-engineered metal building ended up costing $100,000 to put in a 15 by 15 roof hatch. So there are other options, knockout walls or removable wall panels that can be considered. But all stuff that's important to consider when you're getting into the detailed design of how would you put in that future vessel. Another option, not necessarily technically challenging, but important to keep in mind, is maintenance of plant operations when you're doing the conversion from gaseous chlorine to liquid feed. Chlorine is obviously your primary disinfectant and a critical piece of the overall water treatment plant. So being able to keep that online while you're doing your conversion and taking your gaseous system offline is an important detail to consider during the design. And then finally, construction schedules. We're seeing construction schedules being impacted by COVID, as with everything else. The demand for materials has gone up, as well as issues with supply chains. GAC vessels used to be 12 to 16 week turnaround time from approved submittals. We're now getting quotes for 40+ weeks. Similarly, on the metal buildings, costs are going up, as well as lead times are going up. So metal buildings are now 40 weeks from approved shop drawings. So now you're looking at about a year from notice to proceed before you get GAC vessels or a metal building on site. So that's impacting construction schedules as well as costs. There are some options to try and mitigate that. We've worked with several of our clients to pre-purchase the GAC equipment. That means you can lock in your price early on in the project, as well as start that fabrication schedule so you can reduce your construction times. That does come with some risks if you want to go after SRF funding. The SRF program doesn't necessarily always like you pre-purchasing equipment because they want to make sure you go through the proper bidding process. We have had success with working with SRF to pre-purchase a GAC vessel for our PFAS water treatment plant project, but that does come with some risks and some close coordination with DEP. So that pre-purchase is something to consider if you want to kind of lock in your pricing at least early on in the project. Just thinking about project schedule, it's really going to be driven by the SRF. Our understanding is that the project has been submitted to SRF for funding. We hope to see the 2022 draft IUP in the very near future, in the next month or so, with likely the final IUP being published hopefully in April. That does fluctuate a little bit depending on when the state gets all their information from the federal government. And then from there, that really dictates the design schedule is to meet all the SRF deadlines. So our proposal would be getting the 25% design done by March, 75% design by August, and the 90% design done by October. And that's really driven by the Part A application for DEP, which is due on or before October 14th. And typically with that, we include our 90% design submittal. So that's the big deadline from the loan application. The other big deadline to be aware of is there must be a town meeting or city vote by June 30th of this year, 2022, to go after the SRF funding. Our understanding is there already has been a vote on this project. The key would just be making sure that that vote would cover accepting the SRF loan and the terms of that. Sort of moving forward from that, project approval certificate, sort of approval of the loan is likely end of the year 2022. They try to target December 2022, but that doesn't always happen. We haven't necessarily received some of those for this year's projects that we're working on. So with that, you're kind of targeting bidding early winter 2022, early 2023, and then getting all your contracts awarded, notice to proceed in the spring of 2023. And the key deadline there, the next deadline is June 30th, 2023. All contracts must be executed by that June 30th deadline in order to qualify for any loan forgiveness or subsidies that the city may qualify for. Another question that came up is what would the design fee look like for this project? It's really hard to give a firm number at this point without working on all those technical decisions that need to happen in that 25% design. The fee could range anywhere from $350 on the low end if it's a simple project with no clear wells and sort of slab on grade type stuff, all the way up to maybe up to $600,000 depending on the design decisions that are made. Some of that's driven by the site investigation, the geotech work, the permitting that's going to be required, or the wetland permitting is necessary, but really driven by the design decisions in terms of electrical upgrades required because of additional pumping needs. If a clear well is needed or a wet well for booster pumps to go through the GAC vessel, that adds a significant cost for structural design. So really getting through that 25% design and defining the project is going to be the key for really setting what that design fee will be.
So how is the design fee determined? Is that something that you come up after the 25% design with a number, or is it an hourly type arrangement?
Typically, we're coming out of 25% design, we would know what needs to be designed so we can work on how many sheets are needed, what disciplines need to be pulled in, how many hours are going to be required for those various items. Typically and then there's a couple options depending on how the city likes to contract. It can either be lump sum or it can be time and materials where we'd only charge you for hours spent, or the other option is lump sum where you just give one fee to complete the design, and then it's sort of at risk for us to make sure we get it done within that number.
Okay.
And then, so just to wrap it up on our end, so why select Ty and Bond? A couple of advantages we think we bring to it as a dedicated and consistent project team. As Tom mentioned, the team we're proposing, we've worked on nearly identical projects across New England. So we have a team that is very familiar with these processes. We can bring those lessons learned from those projects to this project. And with those projects, we have a proven track record of delivering these on time and on budget. We're ready to start the project immediately from notice of award. As I showed on the draft slide, there are very tight schedules for SRF funding if you do get approved. And those are ones that cannot be missed if you want to maintain your SRF funding. So we're ready to start on this project immediately. We also, as Ty and Bond, we put a high level of importance on our service and responsiveness and communication. We only work in New England. As Tom mentioned, we're a New England firm. So we pride ourselves on our delivery and our client service to our clients in New England, because a repeat work for clients in New England is what drives our business. So we put a high importance on serving our clients. With that, I'd just like to open it up. If you have any questions or comments, we're happy to address them.
Can you explain to me the SRF loan forgiveness? Say that, for example, we talk about the cost. We were thinking it might be 3.6 million, but say it ends up being twice that. Would we be able to get loan forgiveness for the full amount, or are there limits on the SRF funding?
There can be limits, because I'm assuming without seeing your application, you probably put in for 3.6. But there are opportunities throughout the process to ask for more money. We've done that, happens routinely. projects, usually they go into SRF with sort of an initial cost, and then the projects kind of morph over time and cost change. So it's very common to go back to SRF. And as long as they have the funding available, they'll typically increase your loan allocation. And with that, if your loan amount goes up, your loan forgiveness or grant, depending on what's available this year, that would go up as well. But it really comes down to how much is available.
As long as that amount is whatever those additional costs are, would be eligible.
Correct. Yeah.
Would be eligible. So are we looking at a loan that may be forgiven but may not be forgiven? Is that correct?
Well, there's two pieces to SRF. There could be loan, and with all the ARPA and everything else, there could also be grant allocation as well. Loan forgiveness is usually it's a function of your median household income and your water rates in Cohasset. So that's really, it's more of an equation that determines your potential loan forgiveness. The grant money is a little bit more of a question mark with all the ARPA and other funding that's out there, infrastructure funding that is brought into the state. Some of the SRF programs are pulling grants into the program as well, which could be independent of median household income.
All right, that could be an issue for Cohasset, where property values tend to be high compared to some other towns.
Yeah, I don't know if Massachusetts has really finalized it, pending what they get from the federal government, but I know other states, they're giving grant regard, and they don't even look at median household income because some of the ARPA money just has to be spent by 2026.
Sometimes too, they look at, instead of doing a 2% SRF, they'll go down to 0% for projects as well as an option for these SRF programs.
Yeah, I guess my
loan amount.
How do we know before diving in?
We don't know until they put out the IUP, which was supposed to be out December 31st, but given the feds just passed their thing on January 6th, the final ARPA thing, that they'll probably be coming out shortly.
But before we would probably know before we actually started construction of how much we're actually going to pay for and how much.
We'll know before town meeting if what the status is.
Okay. All right.
I have a question. How are the tanks serviced?
The GAC vessels?
Right, to clean them?
So the biggest thing with GAC vessels would be removing the media and putting in fresh media. I don't know if can you see my pointer on the screen?
Sure can.
So these are smaller vessels. These are only 8-foot diameter. But you can see this stainless steel pipe here. That's a GAC fill line. It's a little hard to see, but there's also a GAC drain line right here. So these are basically, they're slurried. The GAC is slurried in or slurried out. So they fill it with water and then they push the media out under pressure through this line. And then they'll push new media in, fluidized media in through this line to fill the vessel back up.
Yeah, so that's media is delivered by a tanker truck, which would back up very close to, and like in this case, very close to the filters, and everything is done with hoses connecting the truck to the vessels.
Okay, but then we might have a problem with the backwash because it contains arsenic.
Yeah, so when
disposal problem with that.
So the GAC media, when it's delivered dry, and it shakes around as it's being delivered. So you'll get fines, GAC fines in there, and those fines will generate head loss. So you do have to backwash the bed when you first put the media in, which stratifies the media as well as gets rid of those fines. So those fines and the water with that can have elevated levels of arsenic. So one of the things to look at would be, will Mass DEP put any limits on what you can do with that backwash? And then also looking at your water treatment plant, because you have existing filter backwash capabilities. So can this be combined with those, or would arsenic cause a problem if you're recycling back to the head of the plant? That would be something to look at during the initial design phase of how to manage that water. Alternatively, you can also segregate it, put it into separate tanks, and dispose of it through alternative means rather than recycling it to the head of the plant.
Now, what size building are we looking at approximately?
From a footprint or a height?
Footprint.
I don't know if we necessarily laid it out, but you're probably in the 50 by 50, something in that range, depending on whether you need electrical rooms, if pumps are going in the building, where the wet well would be located. But something on that order of that magnitude would be my guess at this point. Height, these are also very tall vessels.
Excuse me, that would have enough room to put an additional vessel in?
Yeah, it could look something similar to this, where you would just have 2 pairs of vessels kind of. So this is 4 8-footers. You would have 12-foot diameter vessels, so bigger tanks and much taller. These vessels, this is a 40,000 pounder in this picture. So you got about 26 feet to the top of this. So your interior building clearances are more in the 30-foot range when you're looking at these bigger vessels.
Mm-hmm. Now, would you recommend going for the 4th vessel right away?
There's
the lag time in getting them.
There's a significant cost to buying it. You're talking about $300,000. So depending on if you have to shave budget, that would be a consideration. If you added a 4th, you would have more GAC on site, so you could extend out some of your changeout frequencies because you'd reduce your loading on each vessel. So you may not have to change them out quite as frequently. In the grand scheme of things, you use about the same amount of media, but you could extend out how often you're doing that changeout from an operation standpoint. But if you have budget limitations based at least on the pilot data that was shown, 3 seems like it should be adequate. And then just leave space for future expansion if something changes with water quality in the future.
We could also set up the bid and the design too, to have that 4th filter as an add alternate in the bid. So we include it in the design and then have that set up to provide alternative bid pricing with the bid. And you can make that decision after the bid whether or not to include it or not.
Okay, thank you.
There's some more question. Gotta get them in.
Okay, if there are no other further questions.
I just have a question here about the disposal of the used carbon. It either gets regenerated or gets incinerated. What is the difference in the cost? Because I know regenerated, the company is going to be reusing it. What would be our probability of regeneration as opposed to incineration?
Typically for the carbon, you're going to go to reactivation, which is when they send it back to Calgon has their own facilities, Evoqua has their own facilities. They'll take it back, they'll burn it, which is what reactivation is. So it'll remove the TOC and anything else that's absorbed, whether it's PFAS or any other chemicals that are in the water. And you have 2 options. You can either, if you have enough capacity, you could take that media back. The only challenge is you have potentially a month of downtime. By the time you ship it out, it gets reactivated and brought back to site. That can reduce costs because you're just taking back your own media. The other option is you can send back your spent media and bring back in virgin media, so new media, and then they'll incinerate or they'll reactivate it for themselves, and then they'll use that media and send it to a remediation site or give someone else a discount on that media. Typically, it's not for water treatment plants. It'd be more for groundwater remediation or other sites that don't need necessarily to know where the media came from beforehand. But those are the typical options with GAC.
Okay, and what's the difference in the cost between getting yours back cleaned per se or getting brand new?
Getting yours back, it's not a significant cost saving. You're not cutting it in half. I forget the most recent cost, but I think it's on the order of 10 or 20% difference. Okay. It's not hugely significant because I still do have to truck it back and forth and burn it and then bring it back to you.
does your engineering cover bid specifications?
Okay, now another thing, does your engineering cost cover bid specifications?
Yeah, yeah. So our engineering fee would be drawings, bid specifications. We can have bidding support services all the way through construction observation and administration.
Thank you.
Okay, thank you very much. That was helpful. Thanks for answering our questions and for the presentation. And I think we would now turn it over to Tetra Tech.
All right. Well, thanks everyone. Thanks for the opportunity.
Thank you.
Thank you very much.
Appreciate your time.
Brenda, do you want to elevate our team to presenters?
All right, hold on one second. Let me get you one at a time here.
One note on the arsenic situation too, just for reference, the existing sludge has arsenic in it from the treatment process. So I'm looking at last year's results. We were at 7.99 milligrams per kilogram arsenic in our sludge sample. So I don't think that sludge from a backwash would significantly elevate a year's worth of alum sludge, given that arsenic level. But you could take a look at that with you guys in DEP.
All right, I think I got 3 of you in there as co-hosts.
Okay, so James, and then Tiffany is the last one.
I got Tiffany.
Okay.
I think I got her. Hold on.
Perfect.
Okay, you should.
Let me know when you can see my screen.
Okay, we can see it.
All right, perfect. Okay, well, thank you for inviting us to the interview. We're really very excited to continue our momentum with the town on this project. Just a brief overview of what we'll cover is we'll go through introductions, primarily the folks on the call, an overview of the team, highlights of some project experience. We're going to discuss the process approach and some key assumptions. We'll also talk about schedule and cost, and then we'll go and answer any questions that you might have. So right off the bat, why choose Tetra Tech? Well, we've got firsthand knowledge of the Lily Pond plant through a number of projects that we've recently completed in the last couple of years. Everyone on our project team from Tetra Tech has firsthand knowledge of the plant through all the processes. You'll see that in the org chart, which I'll go through in a minute. We have a thorough understanding of the treatment performance and operational requirements that the town is trying to meet for this particular project. We have a local responsive staff, and we've included industry leadership on all aspects of our team delivery, our delivery team. And the depth and breadth of available resources is vast. You'll see in the next slide after this that we've got many resources in the Northeast, New England, and across the country. So on the call today and in the presentation is myself. I'll be the principal in charge. Tiffany is our project manager. James is our design director and really our expert. And Mark Rigrotti has been included. He's going to lead the civil site aspects of the project, but he also has extensive experience in permitting within Cohasset through a number of boards and projects that we've done recently in the past. So the overview of the project team, this is really your management team. Myself as the point of contact and principal in charge, Tiffany as project manager, and James. We have collaborated very closely on other projects, including the THM study for the project, the pilot study, and the pilot study report. So all of the folks in process, structural, electrical, all the disciplines that support the project know the plant, have been through the plant. When we did the CIP project, we had the opportunity to bring a lot of our supporting staff in and learn the plant and understand what it can and can't do. We've brought on Novus and Chapel to support the geotech and the survey aspects of the project. They've already been out to the site. They've given us detailed proposals for their work. We just have to give them some direction after the workshop as to where to focus for the footprint of the GAC building, and then we'll have them engaged and off and running. Tetra Tech locally has over 300 professionals in Mass, 500 across the Northeast, and we're a firm of 21,000 worldwide. So we have a strong depth of resources. We've included a fair amount of information on our relevant project experience in the qual statement. Tetra Tech is the #1 firm. We've been the #1 firm in water for 18 years running, and that's judged by Engineering News Record. So a reliable, independent organization that looks at firms across the country, across the world, and we have maintained that #1 status for a period of time. Again, our team is built of both local and industry leadership, and we've had success on many projects across the country from concept through construction. Now, in addition, we've also added some additional examples in our qual statement, but particularly on the aspects of what you're asking for in this particular qualifications package on siting design through construction administration. These are just another few examples of work that's been done by this team. I'm going to turn it over now to James. He's going to walk through the process and the improvements and then talk about some key assumptions.
Thank you, Tony. Just to kind of walk the commission through the existing process, just to place the improvements in context. Currently, water was withdrawn from Lily Pond via a set of raw water pumps. It then goes to the rapid mix basin where chemicals are added for removal of color, organics, suspended solids, pH adjustment, and taste and odor control. From there, it goes to a set of flocculation basins, basically where the water is slowly mixed with the chemicals to form particles that are large enough to settle. It then goes to the 2 sedimentation basins where the solids are separated from the liquid, and the clarified liquid then goes to a set of 3 filters for further clarification of the water. It then is fed a gas chlorine solution for disinfection. It goes in the clear well to get the required contact time, and then it is pumped out into the distribution system. So in this particular project, what we're going to do is we're proposing to add GAC between the filters and the clear well so that we can reduce the amount of total organic carbon in the water, which reacts with the chlorine to form disinfection byproducts. And the setup schematically is we would tie into the filter header, provide a set of transfer pumps and a small wet well. We would pump the water under pressure to 3 GAC contactors, and then we would return the water to the line to the clear well. Then the companion improvement, there are currently 2 chlorination points, one for primary disinfection before the clear well, and a second one as the water leaves the facility for secondary disinfection. So the second part of this project would be to replace the existing gas chlorination system with a sodium hypochlorite feed system. And then this is an approach to installing the sodium hypochlorite feed system, where in the existing chlorine storage cylinder storage room, we would install a bulk hypochlorite tank. We believe that 2,500 gallons would provide up to 30 days of storage of sodium hypochlorite, in addition to some additional volume, so that you don't have to drain the tank completely before you refill it. Then in the chlorine feed room next to it, we would install 2 sets of chemical metering pumps to basically send the sodium hypochlorite solution to the 2 existing application points. Then the GAC system, we would pick the water up, as I said, from the filter header, go to a small transfer wet well, pump that water into the GAC facility, and then return it to the clear well piping. This is just a very basic layout of what the GAC system might look like if we use a quad layout. We've also done these in linear layouts, and that would be determined initially based upon how the facility fits best on the site with minimal disruption to the existing improvements there. And there would, all right, I'll move on.
You want me to back up, James?
No, I was just going to say that, you know, in addition to the vessels, we would need to provide HVAC equipment to climate control the building, and we would provide roll-up doors in appropriate locations so that it would make it easy to do the carbon change out, which also means when we site plan this, we need to make sure that access is provided to the building so that change out can be performed. And the way that we've envisioned this, and it's one of the assumptions, is that this building will be dedicated just to the GAC system, and there won't be any other companion uses in the building. Okay, Tony. So some key assumptions we've made about the sodium hypochlorite system, as we showed on the preceding slide, we believe it's feasible to locate the new equipment within the existing gas chlorination storage and feed room. One of the things I didn't point out on the previous slide, we would be installing a roll-up door on the storage area so that we could bring the tank in. Another assumption we've made that would have to be investigated during the 25% design is that the existing structure can support the load from the new bulk storage tank. Another thing that we would need to work out with the building department is the classification of the building to determine whether they would require fire sprinkling of the building. We would need acceptable access for bulk deliveries. It is located during the adjacent to the existing loading dock, so we think that is probably a reasonable assumption. And one more assumption is that we would contact the sodium hypochlorite suppliers to make sure that we could cost effectively receive smaller delivery quantities, because that 2,500 gallon tank probably maxes out the storage in the existing room. And if we needed to more storage to accommodate a full delivery, which would be a little over 4,000 gallons, we would have to make another arrangement for the bulk storage. Moving on to the GAC system, as we previously stated, we have assumed that the equipment will be housed in a pre-engineered middle building with a shallow foundation system similar to the existing structure that's there. The town may want to go with something different to match the existing architecture. That's another issue that would be handled during the 25% design. We have also made the assumption that the building would be dedicated to housing the GAC contactor vessels and other restrooms. Employee facilities would not be located within that building. There is on the original plans for the facility, it shows the filter header being stubbed out to the outside of the building. That would be the point at which we would propose to connect so that we didn't have to work inside the building for that. We would place a wet well next to that, right next to the building with the transfer pumps to the GAC system. As part of the CIP study we did, it noted that a total electrical load study should be done. So another assumption that's being made here, not the internal electric system, but that the utility feed and transformer would be adequate to supply any additional load that might be created by these improvements. And that assumption is there because that would involve additional time and expense to coordinate with the power company. And then the last assumption to make this most cost effective is that we can locate the building in such a way to avoid any significant impacts to any ecologically sensitive areas. And with that, I'm going to turn it back to Tony.
Okay, thanks, James. So a lot of those key assumptions and the discussions surrounding them will really take place in the initial design workshop. And what we've laid out is a schedule, and we feel confident in this, that we can achieve the project design from start at the design workshop to finish within a 6-month period. We've also provided a very detailed labor breakdown as requested by the RFQ in our qual statement. So you can see the level of participation by each of the team members in that overall detailed labor breakdown. So that once we get underway with the 25% design and we've had the workshop, we see that being completed within 2 months. And then we'll have halfway through that or partial way through that, we'll have an idea of where the building will be located. So then we can engage the surveyor and the geotech team to go out there and do the borings and provide the geotech report back to us. In the meantime, final design will commence right after the preliminary work and then be completed over the next 3.5 months or so to get us to the point where we can go out to bid. Our experience with the permitting process, both with DEP and with the local Cohasset different departments, is that the objective would be to engage everybody early. We've worked with DEP through the process of getting the initial pilot study done and approved, and also in the loop relative to the PFAS grant that we were able to achieve through them. So DEP has been involved with this particular project and other projects in Cohasset fairly closely. And we've got a good working relationship going with them. So we start the permitting process early. We sit down with the various boards and commissions that will be involved in approving this to get them to understand what the project is all about. And then as plans become available, we go back to them, file applications, and actually meet with them, walking through the plans. So we get to the point towards the end of the project where we can have the final meetings and approvals in time to go out to bid by the 6-month period. Our bidding assistants will collaborate with you and the town to make sure that we incorporate what the department prefers for the front end documents, and we'll get those documents out to bid and expedite that process. Now, I'd just like to close by saying that we've got great momentum going on this. We've successfully applied for grants on behalf of the town in the past. There are a couple of PFAS grants that are currently available. So when it comes down to early action items like identifying in the workshop what possible equipment pieces and components we might be able to put an early contract out for to procure those ahead of time for the town, would also look at the ability to pay for some of that with these grants. So that's something that we can get into in more detail during the workshop. But you can see that getting off to a good start and hitting the ground with the town's team and the plants team is going to be key to making sure that everything goes smoothly throughout the process. So through effective partnership, a sound approach, and cost-effective, high-quality solutions, we certainly believe we're the right team to continue to work on this project with you. And with that, we're happy to answer any questions or any other discussion points you'd like to cover.
I have some questions. Thank you very much, everyone, for the presentation. I thought it was excellent, as was Tish and Bond. One thing that Tish and Bond went through was kind of the risk analysis and their design fee estimate. And I'm wondering if you guys could give it something similar. They said, for example, they thought they'd be in the range of $350,000 to $600,000, and that our number of 3.6 was very aggressive, and I think they agreed it could potentially be cost a lot more. So I'd like to get your thoughts on those same points.
Yeah, so let me take the first pass at that, and then James and Mark and Tiffany can add in if they'd like. So we've been looking at this very closely for some time, and we're confident with the $3.6 million number. However, that's based on a lot of the key assumptions that we've made. So for example, if you change the architectural appeal of the building, that's probably going to add some cost on the design side.
We understand that.
What we have estimated, and again, you'll see a very detailed hourly breakdown in our qual statement. So our range in cost is slightly lower than what Ty and Bond has presented. We're in the $300,000 to $400,000 range for design. And again, that upper limit depends on some of the answers that come out of the workshop. So we have, I don't have the spreadsheet in front of me in terms of the total number of hours, but that puts us kind of right in the sweet spot in that range of $300,000 to $400,000. And again, no one can predict what the cost of materials and construction will be as we go into the future. However, based on a number of other similar projects, we believe that that $3.6 million number is trustworthy. James, do you want to add anything to that?
Well, I guess I would say in terms of cost estimating, I think the cost part of it is reasonable. In other words, there's $1 million in there for the GAC equipment. There's $1.5 million in there for the building, which is close to $600 a square foot, which is certainly more than reasonable. And there's another $1.2 million in there for doing the piping and some of the ancillary work and the sodium hypochlorite system. But, you know, so that's cost. What is difficult to estimate is what somebody is willing to do the project for. And that could be a totally different number. It depends upon market factors, how busy people are, what schedule you give them. So I think from a cost standpoint, I think the cost is reasonable. From the bidding standpoint and the very rapidly changing situation in the market, it may be aggressive.
Commissioner, much like what Ty and Vaughn had discussed, is that we see once we have that initial design workshop, we'll have the ability to go back and just do a truth check on the estimate that we've developed. And then, of course, during the various steps of design, as we advance the level of detail, we can then update any estimating that's necessary. And Mark Negrotti has a strong construction background, and he would lead that effort, but we would check that against other industry factors and local area factors, meaning what's going on with the contractors and their level of interest, their level of availability. So it's an ongoing, somewhat dynamic process, but all looking to make sure that as the project gets close to bid and close to that decision point in June for the town to line up the funding, that you have the best numbers available.
One follow-up question, if I can. Tyson Bond had said they would do the design fee either one or two ways. One would be time and materials, or the other would be kind of a fixed lump sum fee. This was after the 25% design was done. Do you give similar options, or how would you do it?
We do, and we think that, you know, based on the way that we've estimated it to date, time and materials certainly would be probably in your favor, because what budget we don't spend, you don't pay us for. So we would try to keep those, as we've done, excuse me, on other projects for you, we try to keep those costs as minimal as possible. But yeah, we do work under similar procurement type. Would probably prefer time and material on this one.
Okay. Thank you. Any other questions, Steve or Lee?
Yes. I did notice that most of the staff that were working on this project are all from out of state: Colorado, Florida, Delaware, and Ty and Bond is basically New England-based engineers. Is there any reason why you're using so many out-of-state engineers on this job?
Well, we're bringing the best of the best to this project and to the town. So I can tell you that all of the folks working on the job are either registered or are registering in Mass to make sure that that's not even an issue.
Yeah, no answer.
Well, you know, Tony, I would just add to that Tetra Tech has design centers in different parts of the country. And because we have that, it gives us the ability to utilize labor so that we can do things as cost effectively and also as quickly as possible. And although location is often a factor, because of COVID, we've been doing projects all over the United States from multiple offices. That's kind of our normal mode of operation now. And, you know, Tony is local there, but most of the work, once we get into the design, will be done in the design centers.
That's a good point, James.
So it's basically all remote work per se, with most of it.
Unless it's necessary to bring people to the site, Commissioner. We have done that many times in the past for not only the Lily Pond work, but for Elms Meadow and the 20-year CIP project.
And I would just throw in, Tony, my son is currently attending the New England Conservatory. And when we were talking about in December, maybe doing a site visit to some other facilities, and I told him about that. And when that got canceled, he was disappointed. So I would be more than happy to
be here as early as and often as necessary.
Yeah.
So, Commissioner, we can mitigate that unquestionably.
Okay, no, I was just wondering, with so many people from out of state, does that add to your cost with travel expenses?
No, it hasn't in the past, and it really won't impact us for this project going forward either.
Thank you.
Well, thank you very much for your time.
I have a general industry question, and I understand if it's difficult to answer, but I'm curious if GAC regeneration facilities are also experiencing volatile costs and schedule disruptions that we're experiencing in the rest of the economy.
James, you want to take that one?
I don't have the answer to that. I have not heard of any shortages there. And I just, while we were waiting here, I pulled up an email just to give an idea from Calgon. They say that a regenerated carbon is about $1.20 per pound, and virgin carbon is about $1.50 per pound, just to give an idea. And whenever they regenerate it, they usually throw in about 20% as makeup. So just to give you an idea, I know that Calgon has been upgrading their regeneration facilities because of PFAS. That's a big market, and they've done the effort to get the air quality tested from their regeneration facilities so that they're able to regenerate the carbon there. Right now, I don't see that as an issue.
Thank you.
Thank you very much.
Just one question. Excuse me, John. One more question. Yeah. What is the difference in the life between the virgin and the regenerated carbon? Do you have any idea?
Well, the virgin is like it says, it's never been used before, so it's a one shot. Then then you have the decision: do you dispose of that and replace with virgin carbon, or do you send it back to them, have them regenerate it? And like I just mentioned, they will add to it, because there's some losses, 20% virgin carbon. So you can keep on recycling that probably forever, because there's always a makeup of virgin carbon in there.
Thank you.
Okay, thank you, everyone. Those were excellent presentations. I'd like to now open it to discussion of the commissioners. My hope was, given the time frame that we're under and the SRF deadlines, that we can make a decision on this today. So I'd like to see Steve or Lee, would you like to start the discussion? Because I would like to have a vote on this today, unless you disagree.
I agree with you, John, if you want to start the process.
Okay. My view of it is, and I'll throw it out there, and I'd like to hear your thoughts. I think both presentations were excellent. I think both companies would do a fantastic job here, and we were very lucky to have them present and have the option to select between these two companies. They're clearly both qualified. They have lots of experience in this area. I personally think I would lean towards Tetra Tech. Their fee estimate's lower, which I think is important for doing the design work, and they also have they're much more familiar with our facility. I think they're equally qualified as far as knowing the information and the system and just doing the job. But I think Tetra Tech, given that they think they can do it, the design fee for less, and they know our facility very well, I think I would lean towards them for those reasons.
John, I would echo that because, you know, Time Bond's a household name, such as Tetra Tech. Even if you're like a newer engineer in the world, you know both those companies. Very reputable. Fortunate to have them both here. It's a hard choice, but since Tetra Tech has been here and done other projects, and you know, and the price too is really, obviously we're not a bank either.
Local. They've done a whole bunch of ones here already.
You know, I think we have to be very cautious of pricing too, because again, we don't want rates to go skyrocket either.
Steve hasn't said a word.
Lee, would you like to?
Okay, well,
your thoughts?
You know, my opinion all along has been I would like to have a local company that has jobs, has done the work in New England, and I really have not seen that from Tetra Tech. All of their facilities that they have been directing us to have been basically down south and out west. And Time Bond is local and has done a lot of local. But that's where I'm coming from.
Okay. I don't think that's necessarily correct. I think Tetra Tech did give us some local facilities, and I do think being able to pull people in from different parts of the country with expertise is not necessarily a bad thing. But that's just my thoughts. I mean, I fully respect your thoughts and opinions, Lee. I think this is a very, very difficult choice.
Jason, I have a question for you. Whoever gets chosen, right? Do they go into the prevailing wage schedule, or it's just?
No, this is professional services, no prevailing wage.
Okay, so that's a good thing. Okay.
All right. Any other comments from the commissioners?
I have no other comments. I would thank both parties for coming in. It was remarkable, even though I didn't really say much. The presentations were well done by both.
Okay, given that, and given that I would like to make a decision today, I'll make a motion that we select Tetra Tech.
I'll second your motion.
All in favor? Aye.
No.
All opposed?
No.
Okay, so the Tetra Tech is selected by a vote of 2-1. Thank you, everyone. Again, I thought those presentations were excellent, and we had to make a difficult choice, and that's what we decided. But thank you.
Mistake. That's my opinion.
Thank you all.
Thank you all. Any commission comments before we adjourn?
No.
Okay, I make a motion that we adjourn the meeting at 11:58.
Second.
All in favor?
Aye.
Aye. Thanks, everyone.
Thank you.
Thank you.